You've been sitting on the couch for 2 hours. Maybe you were deep in a TikTok scroll hole. Maybe you were binge watching a show. Suddenly you realize you're thirsty, or the doorbell rings. You stand up, fast. For a split second, you're fine. You take a step, but then it hits you. The room tilts. The edges of your vision start to get fuzzy. It's like someone is turning down the dimmer switch on the world. You hear a high-pitched ring, or maybe everything sounds like it's underwater. You have to grab the back of the sofa just to stay upright because your legs feel like jelly. We call this a head rush. Doctors call it orthostatic hypotension. But let's be real about what this actually is. For about 5 seconds, you are technically in the process of dying. Okay, that's a little dramatic, but strictly speaking, your brain is suffocating. Gravity is trying to kill you, and your heart is frantically trying to save your life. Today, we're going to slow down those 5 seconds of panic. We're going to look at the absolute chaos happening inside your body, from the physics of being a bag of water to the microscopic alarms going off in your neck, to find out how you manage to stay standing at all. To understand the head rush, we have to talk about fluids. Humans like to think we are solid, sturdy creatures, but we aren't. We're basically tall, squishy towers of salt water wrapped in skin. When you're lying down, sleeping, chilling, physics is easy. Your head, your heart, and your feet are all on the same level. Your heart doesn't have to work that hard. It's just gently pushing blood sideways. But then you stand up. The moment you go vertical, the rules of physics change. You've just created a gravity problem. Suddenly, your blood has weight, and because liquid wants to go to the lowest point possible, gravity grabs about 1 liter of your blood. That's like 2 large water bottles worth, and yanks it straight down into your legs. Now, here is the design flaw in the human body. Your veins are stretchy. Think of the arteries, the tubes taking blood away from the heart, as stiff garden hoses. They hold their shape, but your veins, they're more like floppy balloons. When that blood rushes down, your leg veins just expand. They billow out to hold all that extra liquid. This is called venous pooling, and it creates a massive problem for the heart. Imagine a pump trying to push water up a hill. Suddenly, the water supply at the bottom runs dry. Your heart goes to pump, but there's nothing in the chamber. It's dry firing. Your blood pressure drops off a cliff, and way up here at the top of the tower, your brain is suddenly left high and dry. Why do I go blind? So your brain is losing pressure, but have you ever noticed that you don't pass out immediately? The first thing to go is usually your vision. Why? Why do you go blind before you go unconscious? It turns out your eyes are absolute divas. Your retina, that light-sensitive patch at the back of your eye, is one of the most energy-hungry tissues in the universe. By weight, your eyes consume oxygen faster than your brain. They consume it faster than your heart. They are metabolic furnaces. And unlike your muscles, which can store energy for later, your retinas have zero savings account. They live paycheck to paycheck. They need a constant, fresh delivery of oxygen every single millisecond. The moment standing blood pressure drops, the pressure inside your eyeball, which is fluid-filled, actually becomes higher than the pressure of the blood trying to get in. It's like trying to open a door against a rushing flood. The blood just can't push through. The flow stops, and because the retina has no backup battery, it fails instantly. The first parts to fail are the edges, furthest from the blood supply. That's why you get tunnel vision. That static or snow you see, that isn't your imagination. That is biological noise. That is your neurons misfiring, sending garbage data to your brain because they are starving. Your world fades to black not because your brain is off, but because the camera has lost power. The muffled world. So your eyes are throwing a tantrum, your ears are joining the party. You know that feeling? The sound gets muffled or you hear a high-pitched ee? That's happening for almost the exact same reason. Deep inside your ear, inside the cochlea, you have these tiny microscopic hairs called stereocilia. They dance around to sound waves. Just like the eyes, these hairs are incredibly high maintenance. They rely on a specific artery that is a dead-end road, meaning if traffic stops there, there's no detour, no side streets. When the pressure drops, those hair cells stop vibrating. They stiffen up. The sound dampening is literally those cells failing to vibrate. And that ringing sound, tinnitus, that's basically a distress flare. It's the auditory nerve freaking out and creating a phantom signal because it's losing oxygen. So picture this. You're standing in your living room. You can't see, you can't hear. Your heart is pumping air. You have about 3 seconds left before your brainstem pulls the emergency brake and forces you to faint just to get you horizontal again. But you don't, usually. You shake your head, blink a few times, and you're fine. How? Who saved you? The squeeze, the secret rescue. This is my favorite part. This is the part where your body proves it's a genius. Hidden in your neck, right here in the carotid arteries, you have sensors. They're called baroreceptors. Think of them like the paranoid security guards of your body. When you're sitting, the blood pushes against the walls of your arteries, stretching them. The security guards are happy. They're radioing the brain saying, "Pressure is good, we're chilling." But the moment you stand up, the stretch disappears. The sensors go silent. The security guards panic. They scream at the brain, "Code red, hull breach, pressure is gone." In less than a single heartbeat, your autonomic nervous system slams the panic button. It dumps adrenaline straight onto your heart. Your heart rate jumps, boom, 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 trying to fight gravity by brute force. But the coolest part? The squeeze. Your brain sends a lightning-fast signal all the way down to your legs. It tells the muscles inside the walls of your veins to tighten. Remember those floppy balloons? Your body instantly turns them into stiff pipes. It squeezes the legs, physically forcing that pooled blood upward. It's like squeezing a tube of toothpaste from the bottom up. This massive surge of blood shoots up your torso, defies gravity, and hits your brain like a tidal wave. The lights come back on. The ringing stops. The static clears. You feel that warmth rushing back into your face? That is the feeling of your body having your back. It's the feeling of 1,000,000 years of evolution kicking into gear to keep you upright, conscious, and ready to grab that pizza. Gravity is a formidable opponent. It never stops pulling. But your body, it fights back every single time you stand up. And I think that's pretty cool. Thanks for watching.